Okay, this is classwork video 9596 showing you what I need you to understand at this point. Looking at tables. We've been using the zero term going backwards by adding or subtracting opposite to use explicit using that zero term. We're going to have you start to now not use the zero term, but that first term instead, as long as you use this little trippy x minus 1 times that slope. Knowing that if I do, those are the same. I could either use the zero term or the first term. They end up being equivalent. If I distribute that, they end up giving me the same exact equation. So they look different with different numbers, but they are actually the same. We call that equivalent. I need you to start understanding I could use both by plugging in 10 to get that same answer. And then the next thing I need you to understand is looking at a table. If we give you something like this is me giving you the X number, giving you the graph, and saying, what's that corresponding Y number for this graph or for this equation? When X is 3, what is that Y number? So that means I start at 3 on the X axis. Don't go to the Y axis, X axis first. And then when I go to 3, I look up or down until I hit that line or find that point. And when I do, I look over to the left, and that number on the y-axis is the corresponding y value. That has to be 14. When x is 3, y has to be 14. And then no, I could do the opposite. I could give you the not x number instead. I could give you the y number instead and say, okay, for the same graph, if y is 11, what is the x number at that point? So that means go to y is 11 first on the y-axis first. Don't go to the x-axis. Go to the y-axis 11. And then look up left or right until you see that line and look straight down, and what you see is what the x number would have to be when at that point y is 11. So x would have to be 2 when y equals 11. Another thing you need to start understanding in terms of these functions. All right, but here we go. Knowing that, I could use both terms of explicit. I could use the first term or the zero term now. So here we go. This one, arithmetic, I'm adding by 7. As soon as you know it's adding by 7, it's going to be a straight line, straight. Knowing that, I could use that to fill in my table using this recursive pattern. I need you to be able to write the recursive equation. Here it is. To find any term, use the 1 before it and keep adding that 7. That is the recursive equation. I'm really not going to have you use it or show it, but I need you to understand how it works. To find any term in the sequence, use the 1 before it and add 7. So take this 24 and add 7. That gives me 31. Take that 31 and add 7. That gives me 38. But don't add 7 right here. Don't want to do that because the 13th term makes you use the formula. I could use that minus 7 going the opposite way from this 10 right here to get the all-important y-intercept, which is 3. And then I need you to know today, I could either use the zero term 3, or now I could use this 10 number. It doesn't matter which one I use, they're both equivalent. So here we go. Using the zero term, that is f of x equals that 7 times x. We've been doing that plus that y-intercept number. Or we could start using the first term, which is this guy. So I could write it like this. F of x, use that same 7 right there, but don't just put x right there, put x minus 1. That is clutch right there, that you write it just like that. And then I add not that 3, I go 1 to the right, and I add that 10 number right there, knowing that these are equivalent. If I took this and distributed that 7, they end up being the exact same value. Watch. If I took that and distributed that, that would end up being 7x minus 7 plus that 10. And if I add that negative 7 and 10, that gives me 7x plus 3. So you can see they are the same. They are equivalent. Doesn't matter which one I use. They are equivalent. All right, let's put them into use. Here we go. First one. Plugging in 13 right here. 7 times that 13. And then when I times that, I'm going to add that to 3, knowing that's one way of getting this answer jumping ahead to the 13th. So 7 times 13 gives me 91. So I could do the 13th term is 91 plus 3. The 13th term is 94. And put that number right here. Or I could use this guy right here and plug in 13 right here. So here I go. I could do f of 13 again, but now I'm going to type in 7 times 13 minus 1, and I'm going to add 10 right there. That's crucial right there. I'm not adding 3. This gives me 7 times 12. You're not really going to distribute there because you have numbers inside there. Just do the math. 7 times 12 gives me 84, which tells you when I use this equation, I get the same exact answer. I get the 13th term for x is 94. They're the same. Doesn't matter which one I use. Need you to know that. All right, last one here is the geometric one, knowing that this guy is timesing by 2. Oops, do that in red. That is my common ratio number I could put right here. I always need to be able to write the recursive equation no matter what, even though I'll probably rarely have you use it, even though when you're filling in the table, you really are using the recursive pattern. So that is the generic form of the equation. To find any term, use the 1 before it and times 2. 24 times 2 gives me 48. To find this next one, use the 1 before it. 48 times 2 gives me 96. That's recursive in action. Knowing that this way is dividing by 2, this 6 divided by 2, but we don't show division by 2 anymore. We show dividing by 2, which is the same as timesing by the reciprocal of 2, which is a half. That still gives me 3 right there. And now I could use this 3, or I could use this 6. My answer is my numbers plug in. So this 6, let's just do it. So first of all, I could either use the 0 term. The 0 term is that 3 right there, times the r number 2 to the x power. I could use that guy right there. Or I could use the first term instead and not use 3, but use that first term, which is 6 times that same 2, but to the x minus 1 power. They are the same. Let me show you both in use. Got to be able to do both. So here we go. To plug in this 9 right here, I'm going to plug in 9 right here and plug in 9 right here. So here I go. First one, define what that first equation gives me for the 9th term, which will be the same for that second. I got to show you. That is 3 times 2 to the 9th. That equals 3 times 2y9 gives me 5, 1, 12. Remember this. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's what that is. And then that times 3 gives me the 9th term is 1,536. Another way I could do it is use the first one instead. So here I go. I could use the first one instead, plugging in that same 9 right here. 6 times 2, put 9 right here to the -1 power. That gives me the 9th term is that 6 times 2 to the 8th. 2 to the 8th is 256, which gives me the 9th term is 6 times 256. And if I times that by 6, gives me that same answer. It gives me 1536. Gives me the same. That number goes right here. All right, there you go. This is confusing. Bring this to your tutor. Have your tutor help you, please. I appreciate that. Thank you.